So we want to find the degree of each of the polynomials that are listed and indicate whether the polynomial is a monomial, binomial, trinomial, or none of these. So we can see that there are three terms, that is term 1, term 2, term 3, which would imply that this is a trinomial. And when we say the highest degree, we are looking for the highest degree of x in this case, because x is the only variable. So the power here is 2. The power there, x raised 1, is 1. An x term is not there. If an x term is not there, then the power is simply 0. The reason being x raised 0 is 1. So anytime you see 1, you can simply put it as x raised 0. And we are to pick the highest of the three. So the highest would be 2. So the degree of the polynomial here is 2. Now in this example, we have negative 7 raised 5 a times b times c. I've got to keep in mind when we look at the degree, we look at the degree of the constant, the variables, not a constant number. So even though there is a 5 in this power, it is the 5th power of 7, but 7 is not a variable. It is a fixed number. So we don't look at that power whatsoever. You could have 7 raised to the power of 100, 7 raised to the power of 500. It doesn't matter. 7 is a constant. So we can only look at the variables, which are letters. So the power of A is 1. The power of B is 1. The power of C is 1. They're all the same, so the degree in this case is 1. Here we have a polynomial that has 2 variables in it. Oh, sorry. The previous problem, it is a monomial because there is only one term. So let's go ahead and determine if it is a monomial, binomial, trinomial, or none of that. So if you look at this polynomial, there are 4 terms. So this is not a monomial, that's not a binomial, it is not a trinomial. So technically speaking, this is a polynomial. But it is a polynomial in 2 variables. One is x, and the other is y. Now, how do we come up with the degree when we have 2 variables? So all we have to do is to look at the powers combined. What do I mean by that? So we have x raised 2 and y raised 1. So the combined degree there is 2 plus 1, so we get 3. So here we just have y squared, no x, so I'll just put 2. Here, the third term, 4x, I have x raised 1, no y terms, so that would be 1. And the last term, it's y raised 5, no x, but the power is 5, so we put 5. And we have to pick the highest of the 4 powers that I wrote, so the highest is 5. So the degree of this polynomial in 2 variables is 5. So in these examples, what we have to do is we have to simplify each polynomial by combining like terms. Anytime we say simplify, when it comes to polynomials, we are going to combine like terms. What are like terms? Terms that look alike in terms of the variable. So what are the like terms here first? So the like terms are x and x squared. So those are two different distinct terms in x. So every single term that's got x in it, I'm going to combine together. Everything that's got x squared in it, I'm going to combine together. Having parentheses always helps. So I can write this as minus x plus 3x. I'm combining the x's. And I pull a negative out of the last two terms. I'm combining the x squared terms. If I distribute the negative back in, I'll get negative 4x squared, negative 9x squared. Now, 3x minus x is 2x. 9x squared plus 4x squared is 13x squared. And that would be the final answer. Now, there is a way to write this in a better form, but we'd have to wait until the next section, and then I'll explain what that is later on. So in the second example, the first step would be to identify the like terms. So should call them the distinct terms. So what are the distinct terms that we have? So x squared y is one of them. X is the other. And the last one is a constant. Constant doesn't qualify. We can just keep it as a constant. But if you have a bunch of numbers, which is what I mean when I mean a constant, you can combine all the numbers together. So I'm going to bring all the x squared y terms close together. So I have 4x squared y minus 3x squared y. Having parentheses always helps. Plus, bring all the x terms together, 2x minus 7x. That leaves us with one term, which is negative half. So I have 4x squared y, and I take away 3x squared y. That would leave me with x squared y. And 2x minus 7x is negative 5x. And the last term is simply negative half. So I'm going to leave that as is. So the first step in this problem is to identify the like terms or distinct terms. Doesn't matter, it's a matter of perspective on how you call those terms, as long as you realize that I'm picking unique terms. So here, a squared is one of them, ab is the other, and b squared is another one. So I'm going to bring all the a squared terms close to each other. So I have minus a squared plus 14a squared, 18ab minus 12ab, minus 2b squared minus b squared. I'm writing it that way because I have two negatives, or else I would have simply put it within parentheses. So it is the same as saying plus negative 2b squared, negative b squared. 14a squared minus a squared is 13a squared. 18ab minus 12ab is 6ab. Negative 2b squared minus b squared is negative 3b squared. And that is the final answer. Now we move on to adding polynomials. If we have a bunch of polynomials, here we have 2 of them. That is the first polynomial, that is the second polynomial, and we have to add them. How do we add them? We add them simply by combining like terms. So what are the like terms? The terms that we have, and we have to look at both polynomials. I have x squared in the first polynomial, x squared in the second polynomial. So x squared is one of them, x is the other term, and the next one is a constant. So our objective is to combine all the x squared terms, the x terms, and the constant term. Since there is a plus in between, when I write it, I will write it as x squared plus. Now that plus corresponds to the plus that's right in the middle, 8x squared, 4x plus 9x, negative 7 plus negative 7. I'm writing that plus again to represent the plus that is right in the middle. So that plus, plus, plus goes back to the plus right there. X squared plus 8x squared is 9x squared. 4x plus 9x is 13x. Negative 7 plus negative 7 is negative 14. And that's the final answer. And keep in mind that if we combine a bunch of polynomials, we will end up getting a polynomial. So the answer here is a polynomial of degree 2. So here we have to combine 2 polynomials that are in 2 different variables, x as well as y. So the distinct terms that I can see among the 2 polynomials are x cubed y, xy, and x. So x cubed y is in both polynomials, xy is in both of them, and x is here, constants there, so I have to write them separately. Because I have one polynomial with a constant, the other with the x term, they don't necessarily have to have the same terms. So how do we go about combining? First, we combine the x cubed y terms, so 7x cubed y plus 5x cubed y. Then we combine the xy terms, so plus negative 4xy from here, positive 4xy from there. That plus corresponds to that plus. Lastly, x term. There is no x term in the first polynomial, so I'm going to put 0. Plus, the second polynomial has 8x, so I'm going to put in 8x. The last one would be the constant term. The first polynomial has 8 as a constant. The second polynomial doesn't have a constant, so I'd put 0. 7x cubed y plus 5x cubed y is 12x cubed y. Negative 4xy plus positive 4xy is 0. 8x plus 0 is 8x. 8 plus 0 is 8. So the answer here would be 12x cubed y plus 8x plus 8. So in this problem, we just have decimals instead of whole numbers, but the process is the same. The goal is to identify the distinct terms or like terms, call it whatever you want to call it. So y squared is one, y is the other one, constant is the other term. So combine all the y squared terms, so 9.3y squared plus 2.6y squared. The y terms, I have minus y plus 4.4y. And the constant terms, 12.8 minus 8.9. So 9.3y squared plus 2.6y squared is 11.9y squared. 4.4y minus y is 3.4y. 12.8 minus 8.9 is 3.9. Now, before I move on to subtraction, I would like to simply say that that positive sign determines the positive sign over there. So keep that in mind. So I put that as negative because positive times negative is negative. Why is that important? When we subtract numbers, you can't switch the order. So when we say subtract this from that, you have to be careful which goes first, because 2 minus 3 is not the same as 3 minus 2. The process, however, is the same. You combine like terms to simplify, but you just can't switch the order. What do I mean by that? Before we get to that step, let's go ahead and write the distinct terms. One of them is x squared, the other is x. The last one is a constant. Two x squared minus, that minus corresponds to the minus in the middle, 20x squared plus 3x minus, again, corresponds to the minus in the middle, but the other term has minus 5x, so I'm going to put minus 5x plus 12 minus in the middle, and there is another minus 7, so minus 7. Parentheses, brackets, they're quite important. Once you familiarize yourself with the process, you don't have to worry about the parentheses, but until you become an expert, it is best that you use parentheses. So 2x squared minus 20x squared is minus 18x squared. 3x negative times negative 5x is positive 5x, plus 12 negative times negative 7 is positive 7. So we will have negative 18x squared. 3x plus 5x is 8x. 12 plus 7 is 19. So as I mentioned in the previous problem, the order matters when we subtract polynomials. So here it says subtract 8y squared plus 4x from y squared plus x. So that simply means we have to write y squared plus x first, subtract 8y squared plus 4x. Now we could go back and say, well, what are the distinct terms? The distinct terms are y squared and x. So y squared minus sign in the middle, so minus 8y squared, plus x, minus sign in the middle, so minus 4x. So y squared minus 8y squared is negative 7y squared. X minus 4x is minus 3x.
So was this the last question?
Okay, so we have to pick the distinct terms. The terms are x cubed, x squared, x, and constant. So first grouping would be for the x cubed terms. So 9x cubed minus 2x cubed. The minus corresponds to the term in the middle. Plus, I have minus 2x squared minus 6x squared. The first minus here corresponds to the minus in the middle, plus 4x minus 4x. The minus corresponds to the minus in the middle, plus minus 7 minus positive 3. So 9x cubed minus 2x cubed is 7x cubed. Negative 2x squared, negative times negative is positive 6x squared. 4x, negative times negative 4x is positive 8x. Sorry, my brain's going one step ahead. 4x plus negative 7, negative 3 is negative 10. So 7x cubed plus 4x squared plus 8x minus 10 will be the answer.